Today is the 24th day of April 1964, and today the government issued its first press release on the signing of the tender for the building of the new Batman Bridge. To discuss the plans, the costs and so on, we speak with the Minister for Lands and Works, the Honourable Mr D.A. Cashion, MHA, and the Public Works Director, Mr R.C. Sharp. Mr Cashion, why is there a need for a bridge on the West Tamar at Whirlpool Reach?
Well, the government have felt for some time that there is a need to bridge the Tamar somewhere in the vicinity of Beaconsfield and Georgetown, and several sites have been investigated, and Whirlpool Reach has been selected as the most suitable site, and this is a reasonable distance from Launceston. I think about 25 miles from Launceston, and we think that this is the most suitable site for a bridge across the Tamar.
Have there been any other attempts previously to link the East and the West Tamar?
I don't think so. I think it has been talked of from time to time, but no serious thought has ever been given to it until now.
Mr Sharp, who are the constructing authorities, and can you tell me something about them?
Well, the constructing authority is the Department of Public Works. The consultants for this bridge is Monsell and Associates of London and Melbourne. The contractor is Lewis Constructions in association with Cleveland Bridge Company of London.
How much will the bridge cost?
The contract for the bridge is about $3.7 million, and with the road approaches and landscaping and approach highways and matters incidental to this bridge, the order of the cost will be about $5 million.
This is the 20th of July 1964, and directly behind us, as you can see, is the site selected for the building of the Batman Bridge across the River Tamar. The bridge is rather unique in quite a few of its features, and when it is eventually built, it's going to assist the peoples of the northwest and northeast coast to a great degree. Of course, to build bridges, we must have people, and two of the men who are right behind this particular project, Mr Steve Cowie, who is the resident engineer, and also Mr Jock Fairweather, who is the project's manager. Perhaps you might like to tell us, Steve, the reason for selecting this particular site.
Well, this site was chosen as the narrowest section of the river in the lower reaches of the Tamar, really, John, and being on the line of future proposed highways to connect the northeast to the northwest.
And the main reason for building here, therefore, is mainly to connect these two areas and to assist the peoples of these particular areas in the future. It's December 1965, and Steve, there doesn't seem to be very much work done at all on the surface anyhow.
Well, John, so much of the start of this job is the preparation for the steel fabrication of the main truss in Melbourne, and also a start on the fabrication of the A-frame tower. Our job on site, of course, has been to construct all these concrete foundations. We've got the abutment over here on the eastern side, these four piers, two of which are on quite deep piled foundations, and then on the western side, the base to the A-frame and this big western abutment here.
There was some underground mining associated with this particular part of the project too, I believe.
Yes, I've got a more detailed drawing of the foundations to this western abutment over here. All this work is in solid dolerite, and we had to burrow down 65 feet down this vertical shaft all through solid rock and come out in either direction and open out these big underground chambers, which are 18 feet by 10, which is the size of quite a good-sized room. These chambers take the support cables for the whole bridge and have since been filled up completely solid with concrete.
Well, here it is Monday the 15th of May 1967, and today we're about to see the commencement of placing the final two boxes on top of the A-frame. Mr Jock Fairweather, who is project manager for Lewis Constructions. Jock, you might like to tell us something about the construction of this magnificent A-frame.
Well, the tower itself in its final condition is 315 foot tall and is made up of box sections varying in size, hollow.
It's a steel box.
A steel box, in fact, generally probably 13 feet by 8 feet and 15 foot tall.
Any particular reason why it is hollow?
Lightness and structure and access to the top. That's the principal reason, I suppose.
And how much would each of these boxes weigh?
Generally about 12 to 15 tons, with the exception of the very top one, which weighs, the two sections at the very top weigh 32 tons each.
what's the procedure in actually getting them to the top of the A-frame?
Well, as you can see, we have a crane platform on this side of the tower with a crane mounted on it. Our method is to raise the sections from beneath up and place them onto the existing erected part and bolt them together, and then the crane climbs up further and so on up to the very top. The crane is capable of lifting 32 tons. This was essential because the two very top sections weigh 32 tons apiece.
Doc, the crane, was it specially made for this project, or was it just a normal type crane?
Pretty well a normal standard crane, but it was modified for this erection scheme.
An unusual feature of the Batman Bridge is that when it's completed, the main span of the bridge will be supported by cables. The stringing of the cables has just commenced, and it's June 1967. Steve, some of the features of the cables.
Well, these cables are generally described as locked coil cables, and these are one of the few imported items in the whole of this bridge. They come from England, where they're made up to the exact length we want in the works and then shipped out. The cables themselves, this is a typical one here we have, John. They're 2 3/8 of an inch in diameter, and they're made up of 168 wires here. The outer 3 layers are wound in different directions, and then the outer wires themselves, you can see, are these special interlocking wires to completely prevent any moisture getting into them, and so stop corrosion in future years. Each wire is galvanized, and when it's been wound into the coil, it's coated with this metal coat, a corrosion protection paint, and this makes the cable completely watertight and should last indefinitely.
What's the weight per foot?
13 pounds a foot, and we've got nearly 3.5 miles of cable in the whole job. So we've got quite a job in stringing these cables. The longest one's about 450 feet.
The cables were delivered from UK on large drums, and the drum mounted at this west abutment on this unreeling frame. The leading end of it was drawn out along the deck, hooked onto a wire from the tower top, and then raised right up to the very top of the tower and connected into the main anchorage beam up there. By that time, the back end had come off the drum, and then the back end was picked up and drawn back into the abutment.
It's just been completed today. Did it take very long?
The whole operation of erecting these 2 groups of 16 cables has taken about 7 weeks.
Now, what about the anchorage?
The actual anchorage is some 15 to 20 feet back within the abutment, and the sockets on the end of the cables are drawn back and placed over the 2 bolts that are protruding from the concrete. In other words, there are 32 bolts on either side of the abutment which carry these cables.
Steve, why don't we see any piles in the middle of this bridge?
Well, the river is over 100 feet deep here, John, and you get very swift tidal flow through here, up to 8 feet a second, and this makes navigation pretty tricky, and the Marine Board, of course, did not want any obstructions in the middle of the river, because they've got quite a few ships going through here.
When do you expect to join up?
Well, we hope to get the truss across about Christmas time this year.
Another aspect of the bridge which is rather unusual, Steve, would be the road decking. How is it unusual than normal road decking?
Well, this is the first orthotropic steel deck on a bridge in Australia. We've used this steel deck rather than the more conventional reinforced concrete deck to save weight. You appreciate on a long span as we have here, the weight of a normal deck takes a lot of supporting. So we've, instead of using the concrete deck, used this steel deck. Now, this deck consists of a 1/2-inch thick road plate, stiffened with these troughs, formed out of 5/16 plate, bent into this trough shape and welded along each side. And then at each end of the panel, we have these cross beams which run right from one side of the bridge to the other.
How is the decking transported to the site?
It was all prefabricated in Melbourne in Johnson Waygood's works, and then shipped over in these large panels on the William Holloman into Launceston.
From the storage spot here, how do you get it out onto the bridge?
Well, we have a mobile crane, of course, that picks them up at this spot, turns them over, and puts them onto the trolley you can see up on the bridge here, and then out under the orange erection frame out on the far end there.
Since your last visit at the scene here at the Batman Bridge, quite a lot of work has progressed, as you have probably noticed yourself. We speak today on the 5th day of February 1968 with the new project manager of the Batman Bridge, Adrian Boyd. Adrian, what remains to be done now?
Basically, the deck panel erection has to go through to completion. There are 18 panels at this stage to be erected.
How long would this particular job take, the 18 panels?
We envisage that by the end of this month, the end of February, the last deck panel should be in and fully welded.
Of course, Steve, this bridge is unusual in many facets. Now, this particular point of the road servicing, you might like to describe this to us.
Yes, John, this is rather unique. It's the first time this has been done in Australia because of the steel deck. The actual surfacing is a 2-inch thick layer of mastic asphalt to be laid right across the roadway, but it involves, first of all, sandblasting the deck, and then a rubber coating of Bostik, and then a further coating 1/8 of an inch thick of rubber bitumen, and then this hand-laid 2-inch layer of mastic over the top of that.
This has been tried in the UK and the continent, I believe, Steve.
Yes, on a number of bridges over there, John, where they've had the steel deck.
It's been proven most satisfactory?
Yes, as we understand it, most satisfactory.
Saturday, the 18th of May, 1968, and the Minister for Lands and Works, the Honourable D.A. Cashion, MHA, in the presence of the Premier and Members of Parliament, unveiled a commemorative plaque and cut the ribbon declaring the bridge officially open. Then Mr. Cashion led the entourage of dignitaries, guests and local citizens across the now completed Batman Bridge.